UL, or Underwriters Laboratories, does not provide a specific definition of above grade in its listing requirements or standards. The UL listing number WCZW E117,713 for the Baja self-contained spa specifically does not cover below-grade installations. UL listings are specific to the intended use and location of the product. However, UL may allow alternative methods of preventing water damage for below-grade spas. Firstly, watertight construction, where the spa is constructed to be watertight and prevent leakage. Secondly, a sump pump system that is installed to remove any water that enters the pit. Local building codes may have additional requirements for below-grade spa installations. Firstly, a free draining location, where the spa must be installed in a location that allows water to drain away freely. Secondly, a watertight pit, where the pit surrounding the spa must be watertight and properly drained. Thirdly, a sump pump system may be required as a backup to prevent flooding. Ultimately, it is the responsibility of the building official to ensure that the installation meets the requirements of the local building code. Installing a spa below grade without the proper approvals and precautions could create a potential safety hazard. When dealing with electrical installations, it's important to adhere to the National Electrical Code, or NEC, which provides guidelines to ensure safety and proper functionality. For example, the NEC outlines requirements for overcurrent protection, grounding, and wiring methods. Overcurrent protection is crucial for preventing damage to equipment and reducing the risk of fire. Circuit breakers and fuses are common overcurrent protective devices. Circuit breakers are resettable devices that automatically interrupt the flow of electricity when an overload or short circuit occurs. Fuses are one-time use devices that melt and break the circuit when the current exceeds a specified level. The size of the overcurrent protection device must be appropriate for the circuit it protects. Grounding is another essential aspect of electrical safety. It provides a low-resistance path for fault current to return to the source, helping to trap the overcurrent protection device and prevent electrical shock. Grounding electrodes, such as ground rods or metal water pipes, are used to connect the electrical system to the earth. Ground fault circuit interrupters, or GFCIs, are devices that detect small imbalances in current and quickly shut off power to the circuit. They are commonly used in areas where there is a risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. Wiring methods refer to the types of conductors and raceways used to route electrical circuits. Common types of conductors include copper and aluminum wires. Raceways, such as conduits and cable trays, provide physical protection and support for conductors. The NEC specifies the allowable wiring methods for different applications. For example, rigid metal conduit, or RMC, is often used in hazardous locations where there is a risk of explosion or fire. Electrical metallic tubing, or EMT, is a lighter weight conduit that is suitable for many general-purpose applications. Cable trays are used to support large numbers of cables in industrial and commercial buildings. Understanding voltage drop is crucial in electrical installations to ensure that equipment receives adequate power. Voltage drop refers to the decrease in voltage along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC provides guidelines for calculating voltage drop and specifies the maximum allowable voltage drop for different types of circuits. The size of the conductors, the length of the circuit, and the load current all affect voltage drop. Using larger conductors or shortening the circuit length can reduce voltage drop. Selecting the appropriate size of conductors for an electrical installation is critical to ensure safety and prevent overheating. The NEC provides tables that specify the ampacity, or current carrying capacity, of different sizes of conductors. The ampacity of a conductor depends on its material, size, insulation type, and installation conditions. It's important to select conductors that are large enough to carry the expected load current without exceeding their ampacity rating. Directing factors may need to be applied when conductors are installed in certain conditions, such as in conduit with multiple conductors or in high-temperature environments. These factors reduce the ampacity of the conductors to prevent overheating. When working with electrical panels, it's essential to follow safety precautions to avoid electrical shock. Always turn off the power to the panel before working on any of its components. Use insulated tools and wear appropriate personal protective equipment such as rubber gloves and safety glasses. Identify and label all circuits clearly to prevent confusion and errors. Inspect the panel for any signs of damage or corrosion. Replace any damaged components promptly. Ensure that the panel is properly grounded and that all connections are tight. Follow the manufacturer's instructions and the NEC guidelines when installing or modifying electrical panels. Understanding three-phase power is important in many industrial and commercial applications. Three-phase power consists of three alternating current voltages that are out of phase with each other. It provides a more efficient and balanced power distribution compared to single-phase power. Three-phase motors are commonly used in industrial machinery due to their high power density and efficiency. There are two common configurations for three-phase power systems, Y and delta. In a Y system, the three phases are connected in a Y shape with a neutral point at the center. In a delta system, the three phases are connected in a triangle shape without a neutral point. The voltage between phases in a Y system is equal to the square root of 3 times the voltage between phase and neutral. The voltage between phases in a delta system is equal to the phase voltage. Grounding systems are critical for electrical safety. They provide a low impedance path for fault current to return to the source, helping to trip over current protection devices and prevent electrical shock. There are several types of grounding systems, including grounded, ungrounded, and impedance-grounded systems. Grounded systems have a direct connection between the neutral point of the power source and the earth. Ungrounded systems do not have a direct connection to the earth. Impedance-grounded systems use a resistor or reactor to limit the fault current to a safe level. The NEC specifies the requirements for grounding different types of electrical systems. Surge protection devices, or SPDs, are used to protect electrical equipment from voltage surges caused by lightning strikes, power line switching, and other disturbances. SPD divert the surge current to ground, preventing it from damaging sensitive electronic components. SPD are typically installed at the service entrance and at branch circuits. There are several types of SPD, including metal oxide varistors, or MOVs, and silicon avalanche diodes, or SADs. The selection of an SPD depends on the voltage rating, surge current capacity, and protection level. Electrical bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault current. Bonding helps to equalize the voltage potential between different metal parts, reducing the risk of electrical shock. The NEC specifies the requirements for bonding different types of equipment, such as raceways, enclosures, and grounding electrodes. Bonding jumpers are used to connect metal parts together. Understanding the NEC tables is essential for electrical professionals. The NEC contains numerous tables that provide information on conductor ampacity, conduit fill, box fill, and other important parameters. For example, Table 310.16 provides the ampacity of insulated conductors based on their size, insulation type, and installation conditions. Table 314.16 specifies the allowable number of conductors in different sizes of electrical boxes. Table 300.5 provides the minimum burial depths for underground electrical conductors. It's important to consult the NEC tables regularly to ensure compliance with the code requirements. The electrical inspections are conducted to verify that electrical installations comply with the NEC and other applicable codes. Electrical inspectors review the plans and specifications for the project and conduct on-site inspections to verify that the work has been performed correctly. They may also perform tests to verify the safety and functionality of the electrical system. Electrical permits are required for many types of electrical work. The permit process helps to ensure that the work is performed by qualified individuals and that it complies with the applicable codes. Working without a permit can result in fines and delays. Understanding motor control circuits is essential for many industrial applications. Motor control circuits are used to start, stop, and control the speed and direction of electric motors. They typically consist of a combination of relays, contactors, timers, and other components. Motor starters are used to provide overload protection and to limit the starting current of motors. Variable frequency drives, or VFDs, are used to control the speed of AC motors. They convert the fixed frequency AC power to a variable frequency AC power, allowing the motor speed to be adjusted. Programmable logic controllers, or PLCs, are used to automate complex motor control sequences. They can be programmed to perform a wide variety of control functions. Understanding lighting control systems is important for energy efficiency and convenience. Lighting control systems are used to turn lights on and off, dim them, and adjust their color temperature. Occupancy sensors are used to detect the presence of people in a room and automatically turn the lights on and off. Daylight harvesting systems use sensors to detect the amount of natural light in a room and adjust the artificial lighting accordingly. Lighting control systems can be programmed to create different lighting scenes for different activities. Emergency lighting systems are designed to provide illumination during a power outage. They typically consist of battery-powered lights that automatically turn on when the normal power supply is interrupted. Emergency lighting systems must comply with the NEC and other applicable codes. They are commonly used in commercial buildings, hospitals, and other public places. Understanding fire alarm systems is critical for life safety. Fire alarm systems are designed to detect fires and alert occupants of a building. They typically consist of smoke detectors, heat detectors, pull stations, and audible and visual alarms. Fire alarm systems must comply with the NEC and other applicable codes. They are commonly used in commercial buildings, schools, and hospitals. The fire alarm system must be tested and inspected regularly to ensure that it is functioning properly. Understanding data communication systems is important in modern buildings. Data communication systems are used to transmit data between computers, servers, and other devices. They typically consist of network cables, switches, routers, and other components. Data communication systems must be designed and installed to meet the needs of the building occupants. They must also be protected from interference and damage. Understanding photovoltaic, or PV, systems is becoming increasingly important as solar energy becomes more widespread. PV systems convert sunlight into electricity. They typically consist of solar panels, inverters, and other components. PV systems can be installed on rooftops or on the ground. They can be used to power homes, businesses, and even entire communities. PV systems must comply with the NEC and other applicable codes. They must also be properly grounded and protected from overcurrent. Understanding wind power systems is another important aspect of renewable energy. Wind power systems convert wind energy into electricity. They typically consist of wind turbines, generators, and other components. Wind power systems can be installed on land or offshore. They can be used to power homes, businesses, and even entire communities. Wind power systems must comply with the NEC and other applicable codes. They must also be properly grounded and protected from overcurrent. Understanding energy storage systems is becoming increasingly important as renewable energy sources become more common. Energy storage systems store energy for later use. They can be used to store energy from PV systems, wind power systems, or the grid. Energy storage systems can be used to provide backup power during a power outage or to reduce peak demand on the grid. Energy storage systems must comply with the NEC and other applicable codes. They must also be properly grounded and protected from overcurrent. Understanding electric vehicle charging stations is becoming increasingly important as electric vehicles become more popular. Electric vehicle charging stations provide electricity to charge electric vehicles. They can be installed in homes, businesses, or public places. Electric vehicle charging stations must comply with the NEC and other applicable codes. They must also be properly grounded and protected from overcurrent.